I'm going to talk about a different serverless platform to the ones you've heard about so far. So you've almost all heard about AWS Lambda, because that's where we started in this journey. Dean talked about Azure Functions, and I'm going to talk about Apache OpenWhisk. And there's a few clues here in the naming. The word open, the word Apache. You've probably heard the word Apache, probably in terms of a web server from the old days. It's still going, I believe, but not so many people use it nowadays as they did. But Apache is also a software foundation where an awful lot of open source software lives that you use day to day and depend on. And Apache OpenWhisk is a serverless platform within this family. Open. It is open source, which means that we can look at that source code, we can understand that source code, we can run that source code. Nobody can take this product away from us. And I'm a little bit of an open source bigot. That's important to me. So that's one of the reasons why I'm interested in Apache OpenWhisk. Obviously, it has a website, and it's something called an incubator project, which is Apache Foundation's legalese for it's not very old. And it's obviously not very old because serverless is quite new. And OpenWhisk is about a year and a half old or something like that. And it's an open source project, as I say, so there are multiple contributors. And you can deploy it yourself. Most of you probably won't, because it's so much easier to use a public provider for your serverless system. So you're way more likely to be using something like Lambda. Or if you're going to be using OpenWhisk, then there are multiple choices. IBM is the biggest public provider of OpenWhisk. They call it IBM Cloud Functions. Then Red Hat have got a service with OpenWhisk. I suppose that's now IBM as well. I'm not sure. Something's going on there. If you use Adobe, and you've got Adobe Creative Cloud, and you use any of their stuff in Creative Cloud for their platform APIs, that is all OpenWhisk as well. We've seen it hosted privately by quite a lot of very large companies who are running their own clusters. So they're running it on Kubernetes or Mesos or whatever internally, and that is quite a big use case as well. As it's open source, it supports every language you can imagine. Long list. The only one I had not heard of before I actually saw it turn up in the repository was Ballerina, which is legitimately a language out there. All the others are great. I got into this because I'm interested in Swift, and I'm also interested in PHP, and both of those are supported directly on OpenWhisk, which is great. With the Docker container system, you can run anything you like. One of my most popular serverless functions that I've got running is running on Perl on this system within a Docker container. We've all heard of Perl, very old school. That tells you something about some of my clients, I think, more than anything else. Little concepts of a serverless system, and OpenWhisk in particular. One thing about serverless and any technology, really, is that we come up with our own words for things that we already had names for. I don't know why we do this. So these are the words I'm going to talk through for this project. We have our sources, the reasons that a function will be executed, and we call those triggers. So because the word sources wasn't good enough, we have the word trigger. So we trigger events, and then they run our actions, which is what you might call a function. So we have got functions, we've got actions. And we join the two together via rule, so we can attach a trigger to our action via rule. We can turn that rule on or off. We can have multiple actions attached to the trigger, etc. And our actions can generate some sort of results. We also have the ability to talk to our actions via the web, via HTTP, and there's obviously a CLI. So that's how the system looks. Those event providers we also call feeds, because again, one word isn't enough. We need to have multiple words. Multiple ways that you're going to actually trigger your functions and get them to do something. Most obvious ones are, we use the word alarms or cron jobs, some sort of database trigger, so something changes in your database, you want a function to run, or in GitHub, or a message queue system. We like Kafka because it's a great open source message queue system. Push notifications, you want a mobile device registers, you might want to run an action. RSS feeds, another obvious way to trigger something to happen. Let's talk about getting started. Here's where we're going to dive into some source code. The most popular language that you'll see for serverless is JavaScript. So I'm going to show you some Python. So, because you may as well. Let's have different language out over here. This is Python. You can read this Python because there's only 4 lines of code up here. We have an entry point, our main function we call it, which dates all the way back to the olden days of C and if not before that. And we have our event parameters, the information about this event specifically. So what parameters we're going to operate on. Going to do some work. Going to get the parameters out. So in this case, this is hello world, so I'm going to get the name parameter. If it doesn't exist, I'm going to use the word world, and then I'm going to construct a message. So that's my business logic happening. It's a hello world example, so my business logic is trivial. And finally, I have to return a result. It's just a dictionary. Vaguely HTTP-ish here, because you can see I'm using the word body. I could also have used headers and status code if I needed to care about those. But I just have to return my information. Side effect of this is that it is trivial to test. All the information comes in at the top, and all the output goes out at the bottom. Nice and easy to test. I like it. Going to deploy it to OpenWhisk. First thing you're going to do is zip it up. You don't need to zip up this hello world example, because one file is dead easy. But as Julian said earlier, in the real world, you tend to have more than one file in your action, in your function. You're going to have some libraries involved. You're going to have more code, because you're going to still be building with reasonable software engineering principles. And that means you don't put all your code in one really, really long function. So you're going to zip up all our files, and then we're going to upload it to OpenWhisk using the WSK command line tool. Because when the Whisk command line tool was written, vowels were in short supply. I don't know why. WSK, Whisk. It's pronounced Whisk. Action, update, pass in what type of runtime that we wish to execute this function on. In our case, it's Python 3.7. Give it a name, hello, and give it the files, the code that we want it to run, hello.zip, and OpenWhisk is happy. We run it from the command line using Whisk action invoke, because the word run was too simple, and as I said, you have to have new words for new technology. So we have the word invoke. We invoke a function. We also talked a little bit about synchronous and asynchronous earlier. So OpenWhisk is by default asynchronous. When you execute an action, it will not wait around for the result to come back to you. So you have to pass in ---- result in order to run it synchronously, and we'll get hello Rob. Magic. This stuff is really not complicated, which is why it is suitable for what I do. How did it do that? One of the really, really cool things about an open source project, as I said, is that you've got the source code, and you can see what it does under the covers. So we can take a look at what's happening in a serverless system. Here we go. It looks something like this behind the scenes. It's API-based. There's Nginx at the front end, which is obviously a reverse proxy that hits our controller. Our controller uses Console, which is a service discovery system, and uses CouchDB for persistence. There's a queuing system. We use Kafka, and we have something called an invoker, which deals with actually running our actions. So behind the scenes, there's a whole number of components in play in order to run your function. When we created that action, this is what happened. Our Whisk command line tool had made an API call to OpenWhisk, hit the controller, did a post with the source code, and the controller dropped into CouchDB and said, thank you. That's all that happened. When we invoked our action, we posted to the controller again. The controller, via the queue, sent an invoke message to the invoker. The invoker grabbed the source code from CouchDB and put it into the action container. The action container ran the code. The result came back to the invoker that put it back into CouchDB because you're going to care about those logs. And then it sent the result back to the controller if it was synchronous. So behind the scenes, that is what happened. The action container, what goes on in there? It's a Docker container. So what's the first thing you have to do? You have to start it up. So we start up our Docker container with the Docker run. It's now running. We then send in the source code. So we initialize the source code into the container. Once our container is initialized, we then send another command called run in order to execute our function. OpenWhisk doesn't turn off your container as soon as you finish running your function. It leaves it running for a little bit, in case you want to run your function again. If you want to run your function again, we don't have to do the first 2 steps. We can just sit in the loop at instantiated and run our function as often as we like, as long as it is frequent. So that first section is called the cold start time, which is one of the reasons why you don't use serverless for real-time stock trading. It takes too long. We have to kick up a Docker container, we have to put the source code into it. That's cold start. Once we have done that bit, we just sit in a loop, running our function as often as we like, and when OpenWhisk gets bored, it will kick this Docker container out, or you stop using it. That's how serverless systems work. So similar to Azure Functions, you can do web-enabled actions directly from your OpenWhisk. So you just simply add the --web equals true to your action, and it is now web-enabled. You get a rather horrible URL, but fortunately, you can ask the Whisk command line tool to tell you what that URL is, and that URL is wonderful for webhooks. Something that's relatively private, works really, really well in the GitHub webhook or in an Alexa skill, something like that. That's where I tend to use them. If you're going to do more than that, use an API gateway. It's built into OpenWhisk, but the OpenWhisk's API gateway, it works the same way as Lambdas or as any of the other API gateways. You can now start routing an endpoint to a particular action. So you start having more control. You can do rate limiting, you can do custom domains, you can do authentication, all the other cool stuff that you care about in an API, but do not want to do yourself. The magic of serverless is that other people do the boring bits. And this is most definitely a lot of the boring bits. So let the API gateway do that work for you. It literally just sits in front of your OpenWhisk, works exactly as you'd expect. Again, it's all done via the command line client, so we create an API entry, and then we can curl to it, but we get a nice URL now. So it's suitable for publishing and being a product in its own right. Most serverless applications are not a single function. Again, as we saw from Gillian's talk, there's an awful lot of components that go into the average application. And grouping functions and grouping actions can be quite important. We call those packages in OpenWhisk. You can create a package, which is a group of functions, a group of rules, a group of triggers, and then you can publish them to other people using your instance of OpenWhisk. So you start being able to share groups of actions, which is quite helpful. And OpenWhisk comes with a number of built-in packages automatically, and then, as I say, users can add their own to them, which is quite helpful. Similarly, we have something called sequences. Running one action, followed by another action, followed by another action, is something you do not want a controlling action to do if the system can do it for you. So if you always want to run 3 actions in turn, get the system to do it for you. OpenWhisk calls it sequence. It doesn't cost you anything extra to do it this way, which is quite nice. There's no controlling action, which is wonderful. So we use those quite a lot when we have multiple actions that need to run consecutively. It's not the only way to do logic in functions. We call it composer. AWS, I think, calls it step functions. I've never used it there, but the idea is that we've got a load of functions, and we want to run some of them based on something else. And you can't read that diagram. So let's zoom in a little bit. Just to the top bit. This is for the Alexa skill. So the first thing I want to do is authenticate to make sure that the endpoint has been called by the AWS Alexa system. And if it fails to authenticate, then I wish to send a failure back to the client that called it. If it succeeds, I want to do something else. So I want to configure my system to work like that. And I can simply create this sort of diagram where I list all my actions and how I want them to be controlled. But I don't draw it, I code it. We've talked about this twice now, I think, so far, maybe 3 times. Infrastructure as code is probably the theme of this conference, because I think we're all saying it on stage. If it's not in source control, it cannot be repeated. And you don't want anything going into production that you can't repeat. So whilst the point and clicky web interfaces look cool, do all the real work in files. That's the way we do this stuff. Similarly for deployment. I like third-party tools for doing my deployment stuff, and the tool I use is called Serverless Framework, which I personally think is an even worse name than serverless, because it's extremely confusing. Serverless Framework is a mechanism by which you can write out in code or in a description file how you want your services to look, and then it will configure your platform to work like that. Very conveniently, it works with every serverless provider, which means that I can learn one tool and I can deploy to AWS, I can deploy to Azure, I can deploy to OpenWhisk very, very easily. Wonderful little tool. Obviously, it's in JavaScript, so we use NPM. And it's just simply a YAML file. So again, we're back to code. Write your code to describe your services, to describe your deployment system, because you can version control it and you can repeat it. This is an example from a PHP project. So my provider is OpenWhisk, my runtime is PHP, and then I can list out my functions. So this is a to-do API. So I have a function called list-to-do. It has a handler, which is the source code, and then I can attach events, which are how is this triggered. The event in this case is HTTP, which means it's a web API, and you can see that API gateway going on here. A GET request to /todos will trigger this particular action. And then I can add all my other actions, and the framework will deploy it all for me. I don't have to remember to click things in the right order. And that's it. That's what I want to tell you about OpenWhisk. OpenWhisk is a really, really good open source, multi-tenant, serverless solution. If you want to run your own one, because you're a fairly large company, then this is a good choice. If you want to run it in the cloud, then, and just use a public provider, then IBM Cloud Functions is remarkably good at this. I quite like my little stuff up there. Plenty of resources to learn up about it. As I said, these slides are online, so you can pick them up there. I'll tweet the link out, so you don't have to click things and whatnot. There's also a book on it, which makes life easier. And thank you very much for listening.